Today we are going to discuss how we count outcomes in a sample space. Now before we get started, you'll see that the bell ringer says, look back at the sample spaces on your notes from yesterday, the very last page. Is there a way we could find the number of outcomes in a sample space without making a model? How do you know this? So I'd like for you to take just a few minutes to fill that out, and then you can select to move on when you're ready. So what you might have found is that for each step within your action, you could multiply your number of outcomes together. And that's what we call the counting principle. So for the counting principle, to find the total number of outcomes in a multi-step action, you want to multiply the number of outcomes for each step in the action. And so we're going to do an example of this. It says use the counting principle to find the number of possible outcomes of the class election. Then check your result by writing out the sample space for the election. So we can say that we can see that we have 3 steps in this action. We have to choose a president, a secretary, and a treasurer. Now for president, we have 2 options. We have Marta versus Ethan. For secretary, we have 3 options. And for treasurer, we have 2 options. So we're going to take 2 times 3 times 2. 2 times 3 gives us 6, times 2 gives us 12. So we have 12 total outcomes. Now it's always important to check this like they ask us to do, so we're going to list these. Probably the easiest way to do this is an organized list. So I'm going to start with the president being Marta, and I'm going to think of all examples where Marta is president. So let's start with where Marta is president and Ben is secretary. So either I could have Marta president, Ben secretary, and Andy as the treasurer, or I could also have Theo as the treasurer. Now let's look at our possibilities where Marta is still president, but then Rosa is secretary. So if I have Marta, then Rosa, I could again have Andy or Theo. So I have MRA and MRT. And last but not least, with Marta as president, but Zach is secretary, I could either have Marta, Zach, Andy, or Marta, Zach, Theo. Now those are all of our possibilities of who could win if Marta is president. So now we want to think of if Ethan is president. And the nice thing about this is our second 2 rows from that first set, all those letters are the same. So I could have Ethan, Ben, Andy, Ethan, Ben, Theo, Ethan, Rosa, Andy, Ethan, Rosa, Theo, or Ethan, Zach, Andy, Ethan, Zach, Theo. And what we see there is that we have 6 by 2, so 12 total outcomes, which verifies what we got over here, that we would have 12 total outcomes. Now sometimes when we look at our sample space, we're going to have to identify outcomes, and there's no quick way around it. And so sometimes the best thing to do is to list our outcomes and identify outcomes that work for a certain event. So this says finding outcomes in the sample space. Given the sample space of an action, you can identify outcomes that have particular characteristics. These outcomes compose an event in the sample space. So we talked about events before with simple events, and these are just the same. They're looking for different outcomes that work for a certain event just with compound events now. So our action is toss a coin and roll a standard number cube. Here's our sample space. And then it says toss tails or roll an odd number. So if I look over at my sample space, one or the other has to be true, or both. That's what we talk about when we see or in probability. So I could have anything with tails, so that would be anything in my bottom 2 rows, as well as any of my odd numbers. So those would be cases that would work. And so we see that we end up with a total of 9 different outcomes in that event. So we're going to look for different outcomes for another event. So this says use the tree diagram that shows all the possible ways boys and girls can be born into a family with 3 children. So it's kind of hard to see our tree diagram here. So I'm going to draw our lines again. So we saw this yesterday when we were looking at making tree diagrams for compound events. But we're going to use this today to figure out how many outcomes work for each of these events. So our first event is to get exactly 2 boys. So when I look through my tree diagram, I can use my branches to figure that out. So the first one I have is boy, boy, girl, so BBG. Then I have BGB, and nothing else in this first set of branches, but if I look at my second set of branches, I end up with GBB, and then that's the last one that we have. Now you may be wondering how I could so quickly figure out that I got all of my outcomes, and this is how. Because if I have 2 boys, then I have exactly 1 girl, and either that girl could be in the last slot, the girl could be in the middle slot, or the first slot. And so because of that, I knew that I accounted for all my outcomes, and I have a total of 3 outcomes in my sample space. Now the next one is having at least 2 girls. So we can use kind of the similar strategy to figure out at least 2 girls. Now let's start off with exactly 2 girls. So we could have a boy, but then 2 girls. We could have a girl, then a boy, then a girl. Or we could have a girl, and a boy. And so basically, for 2 girls, I'm going to have exactly 1 boy. So either that boy is going to be first, second, or third. Now notice here, though, that this says at least 2 girls. So we got all of our cases of at least 2 girls, but then we also have a case where all 3 babies are born a girl. And so we also have to account for our 4th case of girl, girl, girl. And so there's 4 total outcomes in that event. Now we're going to do one more example. In this example, we can kind of use some different strategies to figure out exactly how many different ways people can finish in the race. So this says, in how many ways can Alice, Becky, Carl, and David finish first, second, and third in the race? And how many different ways can Alice finish ahead of David? So we see that we have 4 people racing, and we're going to figure out how many ways they could be in first, second, and third place. So we're not even worried about 4th place. And so I have kind of 3 things that I'm going to multiply. I need to choose somebody for first place, first, second place, and for third place. So that means I have 3 actions, or 3 steps in my action. And so first place, we see that we have 4 options. We could choose Alice, Becky, Carl, or David. For second place, though, once somebody already wins the race, then there's only 3 people left. So say Alice wins the race, then we only have 3 people left in the running for second place. And so unlike some of the others where my outcomes weren't affected, this is kind of like a dependent event here because my second choice is affected by how many or who got first place. So now I only have 3 people, so my number decreases. Now once somebody gets second place, then I only have 2 more people in the running, which means in third place I have 2 options for who could get third place. And when we take 4 times 3, which gives us 12, times 2, that's going to give us 24 ways Alice, Becky, Carl, and David could finish in first, second, and third place. So that's the first part of this problem. Now the second part says, in how many ways can Alice finish ahead of David? Now I want to be able to save my time if I can. And I honestly don't want to have to write out every single of those 24 ways, like Alice, Becky, Carl, David, Alice, Becky, David, Carl, and so on, because that would take a while. And so I want to use a little bit of a different strategy. So what I know is that each of these outcomes is equally likely. So Alice, as far as what we know, Alice is just as likely to finish ahead of David as David is ahead of Alice. And so because of that, I know that half the time Alice's name is going to show up ahead of David's, half the time David's name is going to show up ahead of Alice. So I can say that half the time Alice is ahead of David. And if that's true, then out of 24 ways, half of those, Alice will finish ahead. So I'm going to take half of 24, which gives me 12. So we have 12 ways Alice finishes ahead of David. So at this point, we're finished with our notes. You have a partner practice to complete. You need to get 100% on your partner practice, and once that's finished, you can start on your digits homework.